What's up, everyone? Just going to go through the answers of this to give you guys one more tool you could use to study. So I'll try to keep this fairly brief and clear. The strongest acid is gastric acid. Remember, lower pH have stronger acid, stronger base, the opposite side. So 7's neutral. Once you go above that, you're basic. The farther away from neutral either way. So bleach is our strongest base on that chart. Each shift in the pH is an increase of 10 times as much H+. So if we're looking at black coffee and we go over to tomato juice, that's 10 times stronger. If we go another shift of the pH, that's 10 times stronger. So going from black coffee to tomato juice to orange juice, 10 times 10 is 100. So remember that this is the pH scale is based on powers of 10. So orange juice is 100 times stronger than black coffee, and by that same logic, we can think about urine versus lemon juice. Lemon juice is lower, right? Lower means more acidic. So more acidic equals more H+ ions. And then if we're comparing distilled water, which is at 7, versus orange juice, which is at 3. So from 7 to 3, we're talking about 4 powers of 10, 10 to the 4th power difference. And that is going to be equal to 10,000, 10 to the 4th. So orange juice is 10,000 times stronger than distilled water. All right, challenge problem, triple spice. We've got a rainstorm. The pH lowers after the rainstorm, so that lets us know that the rivers become more acidic. We want to calculate exactly how much concentration of H+ there is in the river before and after. It gives us some tips about how to write that answer in either scientific notation or full answer is fine. So you can grab your calculator for this one, and the formula is given to you. So if we want the H+ concentration in moles per liter, it's going to be 10 to the negative pH. So this is saying before the rainstorm. So 10 to the negative 6.7 power. I need a calculator for that. Using that Google calculator. Gives me a string of decimals. I'm just going to round that because there's only 2 sig figs here. So it's 2.0 times 10 to the negative 7th. Don't forget to put units. The units for concentration that we usually use are moles per liter. If you wanted to write that whole number out, let's just do it over here. 10 to the negative 7th, so 0.0070 zeros. So 720 moles per liter. So it's not a lot, right? There's a low concentration of acid. Even when we call something acidic, it doesn't necessarily have a lot, right? It's little shifts of the pH scale can have huge implications on how strong something is. So after the rainstorm, same process, 10 to the negative 6.5. This one I'm just gonna do as scientific notation. And it's about 3.2 times 10 to the negative 7th. Again, moles per liter. So I can see that from here to here, the amount of H+ in there went up significantly. So sometimes when rainstorms happen, the rain is more acidic than the water that was in the river before, and we can see like actual real increases in the acidity level. So it increased because we see more H+ there, and that agrees with what we know about the pH scale, right? When the pH drops, that means more acid. All right, numbers 7 and 8 are based on a cookie recipe. I'm gonna still show these using dimensional analysis because it can be helpful to see that process. So I'll just explain it this first time, and the next bunch are really similar. So 36 cookies, right in my units, times it by a conversion factor. And then how many chocolate chips? So I'm looking for chocolate chips in my answer. I wanna make sure cookies cancel out. And I would just look to my balanced equation for the numbers. There are 60 chocolate chips for every 12 cookies. So 60 over 12. See those cookies cancel out. Use my calculator. And it is 180 chocolate chips. There are other ways to do this, of course. But when it comes to doing this for chemistry problems, it's much, much easier to set it up using this system. All right, it's called dimensional analysis. That way we make sure we see those units cancel out and we're not kind of guessing whether we multiply or divide. We can really see it happen clearly and make sure that we're making the right moves. So next one, same concept, just bigger numbers. I want to make this many cookies. Again, I want to figure out how many chocolate chips. So chips on top, cookies on bottom. See those cookies cancel out, and there are still 60 chocolate chips for every 12 cookies. So same exact process, just a bigger number. All right, the reason that that's a useful tool to recall is that chemical reactions can be thought of the same way, like recipes, but it's not as easy to picture what's going on. So for number 9, if I want to make 48 water molecules, I can see that water is a product of this reaction. Let's write that out, 48 molecules of water. And I'm asking how many of these molecules do I need to put in? I can see that it's a 1:2 ratio. So I could do this in my head and say, okay, it's half as much, 24, but I'm still gonna show this with dimensional analysis because it's real easy to get that flipped around once the numbers are harder to picture. So I want CH4 molecules. I wanna cancel out water molecules. And then there are 2 water molecules for every 1 CH4, right? That's just 1 CH4 right there. Cross those out. 48 times 1 over 2, 24 molecules of CH4. All right, same concept, 0.0036 moles of CO2. Moles and molecules are not the same thing, but you can think of them as the same concept. It's just that a mole is a lot of molecules, but it's like a steady number that we can actually use, right? Remember, a mole, if anything, is 6.02 times 10 to the 23rd. 1 mole equals 6.02 times 10 to the 23rd molecules. So the ratios are still gonna be the same. So I want moles of oxygen. I want to cancel out moles of CO2. And I look at my relationships. There is 1 mole of CO2 for every 2 moles of oxygen. Cross those out, bam. And 0.0072 moles of oxygen. Spice problem. I want to make 13.8 grams of water. How many grams of CH4 do I need? So the moles are doubled, twice as much H2O as CH4 gets put in. But in order to do this, I have to convert from grams to moles and then back. So this is going to be actually a 3-step conversion. It does give us a hint. So when these come up on the midterm, if they're multi-step problems, you'll get a little bit of guidance so that we're not kind of overwhelming our brain. But take it slow, think of each step logically. We want to go 13.8 grams of water, turn that into moles. Now, how do I know this number? I don't know off the top of my head how many grams per mole for water, but I do have a periodic table. I'll be right back. Water's H2O. So I can see on my H, there's a mass of about 1. And on my O, there's a mass of exactly 16. So I want to think of H2O. H2O. 2 times 1 for the hydrogens, 16 for the oxygen. It'll work for any compound. Just add up the individual masses that make up that molecule. So the mass of water is 18 grams per mole. Plug that in. I'm gonna just keep showing this all in one 3-step unit conversion because I don't have too much space here, but you could calculate that and then go to the next step. I'm just gonna save myself a little bit of time. All right, so that's gonna give us moles of water. We need to be getting our answer eventually in CH4. So let's go from moles of water to moles of CH4. And I can get mole to mole conversions right from the reaction. So there is 1 mole of CH4 for every 2 moles of water. And then lastly, I want grams of CH4 because I can't measure moles directly. And again, I can use my periodic table. CH4 12 for the carbon, 4 times 1 for those hydrogens. So that's going to give me 16 grams per mole. Cool thing about this, we can see that we did it right because the units are all going to cancel. Grams go away, moles of water go away, moles of CH4 go away, and our answer is just going to be in grams of CH4. When it comes time to plug this in, I could, again, do it step by step. 13.8 divided by 18, divided by 2, times 16. Or I can calculate the whole top, 13.8 times 16, and then divide it by 18 times 2. All right, trust your math skills there. But regardless of which way you do it, you should get the same answer. Of about I'm gonna keep 3 sig figs because I see that in my problem, 6.13 grams of CH4. All right, last section, more unit conversions. Mr. Ian's in South Korea. He's at the BTS concert. He needs to buy that t-shirt. And he sees that it costs this many won. That's the unit that they use in South Korea. He wants to figure out how many American dollars that is. So he's gonna convert that, 38,000 won. Need to figure out that conversion ratio. And it changes every day. So I'm just going to Google and I'm asking it won to US dollars. If this type of problem's on the midterm, it will give you the conversion factor. And it's $0.00076 for every 1 won. He's spending about 29 bucks on that thing. Worth it. All right, we just went over this for the challenging problem, so I'll still write out the work, but same concept, NH3, 14 for the N, 3 times 1 for those H's, that's gonna give me 17 grams per mole. Methane, we just did, that's 16. Mustard gas, 12 times 4 for the carbons, 8 times 1 for the hydrogens. Chlorine is about 35, and then 16 for the oxygen, so a little bit bigger number, but same concept. It's gonna be about 142. And then ibuprofen, like the medicine or the ingredient in Advil. 12 times 13 for the carbons, 8 for the hydrogens, 16 times 2 for the oxygens. About 196. All right, Ramir needs this many moles of aluminum to do a reaction. How many grams does he need? So 8.5 moles of aluminum. Just want to times that by the grams per mole. Look it right up in the periodic table. So for aluminum, it is about 27. See those moles cancel out. We're left with just grams in our answer. Nasir needs this much copper sulfate. How many moles is that? So notice that I'm putting moles on top now because I want those grams to cancel out. All right, that's really important, but the periodic table still tells me how many grams there are per mole. All right, so this is why you don't necessarily need to memorize anything. Just need to understand how this works mathematically and then use the tools that you've got. All right, copper sulfate. You could use your periodic table. You will need to on the midterm. I'm gonna Google that. The molar mass is about 160. So keeping those 3 sig figs, 0.114 moles. I see those grams cancel out. All right, 2-step problem. Makai's got a solution of hydrobromic acid. Its concentration is given. Unit on that is moles per liter. Our graduated cylinders that we use in lab usually measure in milliliters, not liters. So that's a common conversion, right? We've got to be comfortable turning from milliliters to liters. It will give you the conversion factor. So let's start there. She's using 200 milliliters. We're going to figure out how many liters that is. Cancel out those mLs, and we can see that there's 1,000 milliliters for every liter. Boom, boom. So it's going to be 0.2. Technically, you should keep all those sig figs. So 0.2000 liters is our first step. I need to know how many moles she has, and here's my conversion factor, right? There's 0.035 moles per liter. So 0.2000 liters times 0.035 moles per liter. If you want to put a 1 down here, you can. All right, there's 0.035 moles for every 1 liter. Cross out those L's. Last one. All right, I believe this is 3 steps again, so I'm going to do them all continuously. But we've got hints. We want to convert from moles of HBr to moles of calcium hydroxide. Then convert from moles of calcium hydroxide to grams. Okay, so that's just 2 steps. So 0.054 moles of HBr. That's what's given to us in the problem. Let's turn that into moles of calcium hydroxide. I can get that relationship right from the problem. There's 1 calcium hydroxide for every 2 HBRs. Then convert it to grams. I'm still going to write my formulas so I really know what I'm doing. Calcium hydroxide. And again, you could use your periodic table, or if you're feeling lazy right now, just Google it. It's about 74. Make sure the units are set up by canceling. Moles of HBr, moles of HBr, moles of CaOH, moles of CaOH. So our answer is just going to be in grams, right? That's exactly what it asked us for. And plug away. Sig figs is 2. So my answer on my calculator says 1.998 grams. Let's go ahead and round that to 2.0 because we're only allowed 2 sig figs in our answer. All right, hopefully you found that useful. Peace.